Okay, I'm going to show you the proof for the expansion of sine A add B, which is part of what is known as the addition formulae. Now, all of these formulas are in the formula booklet, and you won't actually have to prove it, but I'm just going to do one, as in sine A add B, and then the rest I'm just going to point you towards the formula booklet and you'll just use them appropriately. So to do that, or to show this, we use this diagram and follow a series of steps and take advantage of what we know about SOHCAHTOA. So one thing to make clear at the very beginning, and is quite a common misconception, is this sine A add B for this angle, for some angle A and for some angle B, is not equal to sine A add sine B. It doesn't expand like when you're multiplying out brackets. It's a bit like the logs in that sense. So that's just something for right now, never do. Okay, so before we get into this, one of the important things that we're going to have to not mark on here is that this angle here must be A as well. Because, and I don't want to draw on it, but if you try and follow this, if you think of the angle, this angle here, not the full right angle, but just this one here, being A because of alternate angles being equal, if this is a right angle, then the rest of that angle must be 90 take A. And so if one of the angles in this triangle is 90, the other is 90 minus A, and the total is 180, then if you just do 180 take 90 minus A, it leaves you with this angle being A. So that's quite important. The other thing then is to establish how are we going to work out what sine of A add B is. Well, next I want to just mark on, so just bear with me because I'm going to... Just bear with me. Sorry about this. So we can do this using SOHCAHTOA. So if all of that is A plus B, then again, due to alternate angles being equal, all of that must be A plus B. Okay, so then we're thinking, okay, if that's the angle, this would be the opposite side. This is a hypotenuse. Oh, this is important actually. This side is 1. Okay, sorry, that should have been on at the beginning. So if we know the hypotenuse and we're interested in the opposite, then we know that sine A plus B is equal to the opposite side over the hypotenuse. And if the hypotenuse is 1, then we can make that 1. And so the opposite side must be equal to sine A plus B. So what we can take from that is, if I want to know what sine A plus B equals, I want the length of this side. Now, I can't just get to it, but I'm going to show you in a series of steps, and it gets fairly complicated, but we are going to show in a series of steps that this side add this side must equal this side, and so we will get an expansion from that root. So I'm going to do that now. Okay, so first step then, if we're just concentrating on this triangle here that contains angle B, okay, then if the angle is B, then this is the opposite side. So I should be able to say that sine B equals opposite over hypotenuse, and the hypotenuse of this right angle triangle is also 1. So this side, in terms of B, must be equal to sine B. For similar reasons, if this, again, the same right angle triangle, this side, this side, the adjacent side, must be equal, well, cos B must be equal to adjacent over hypotenuse, which is adjacent over 1. So the whole of that side, this long side here, must be cos B. Okay, remembering that ultimately I need this side and this side expressions for those things. I'm going to now I'm going to focus on finding this side, but it's not really going to be possible if I consider literally this side. So I'm going to look at this side here because it's contained in this right angle triangle that's got angle A. So it's this one here. And I want this side. And again, that is the opposite side. So I'm interested in the opposite side. So again, I should be able to say that sine A is equal to opposite the side I'm trying to find, this one, over hypotenuse. Now the hypotenuse of this triangle is cos B. So it's going to be opposite over cos B. And so opposite equals sine A times cos B. So I'm going to write that on, sine A cos B. And that's that side, and therefore that must be that side. So that's part of my job done. So it's going to be, part of my expansion, okay, is going to be that sine A add B equals sine A cos B add whatever this side, whatever expression we can find this side to be. So we'll do that now. We're now interested in this side. Okay, just from the top here to this point here, because we already know the rest. And we're going to do that a similar way with this right angle triangle here, okay, the one that's just upright. And we've got this angle A. Now the side in question is adjacent to the angle A, and we have the hypotenuse. So it should be that the case, and it is, that cos A is equal to the adjacent side, which we don't know, or we're trying to find, over the hypotenuse, which for that triangle we've found to be sine B. So adjacent must be equal to cos A sine B. I'm so sorry about the lack of professional video quality. I don't have one of those stands. I'm just doing this on my phone, to be honest. I might go into work next week and try and find and steal an actual webcam, but for now this will have to do. I thought this would be a bit more clearer than Mr. Medley's video. I thought I probably will post it, but then I'll leave it up to you. But anyway, so back to it. This question mark, which we're trying to find, we've found the expression for that is the adjacent equals cos A sine B. So I can actually write that in now, cos A sine B. And so what the ultimate aim was to find an expression for sine of A add B. Well, we've proven, okay, we've not done anything dodgy here. It's all legitimate. We realised that the way to show this would be to say, well, it's got to be equal to this side at this side. And we have, through a series of steps, using SOHCAHTOA, we've not done anything dodgy, shown that the correct expressions for this side is sine A cos B, and the correct expression for this side is cos A sine B. So our initial question, what is sine A add B? Another way of writing sine A add B is that it is equal to sine A cos B add sine B cos A. And we've shown that, that's the proof. So that's one of them. The rest of them can be shown because there's formula for sine of A minus B, cos A add B, cos A minus B, and tan A add B, tan A minus B. Collectively, these are known as the addition formulae. You don't have to be able to prove them, but doing this kind of thing with SOHCAHTOA, as we've seen in some other parts of the course already, is a really key skill in the sort of broad trig topic. The application of these formulae is something we'll be working on in the next couple of lessons. Yeah, so hopefully that was clear. I'll send it for you to watch and make notes on.